So using this binomial theorem, we have to explain this 0.99 whole to the power 5. So we can stop here because we have to take up to 4 decimal places. So the other 2 is not required because we will round it off to 4 decimal places. Remember, term independent is nothing but we need to equate the coefficient of x with respect to the power 0. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. So here we are at the revision class of the chapter Binomial Theorem. Most importantly, in Binomial Theorem, you will get 1 4-mark question and 1 5 marks question. Let us see the distribution of the marks from this chapter. So from the chapter Binomial Theorem, from part D, that is 5-mark question, you will have 1 question, and from part E, in the form of 6 plus 4, you will have 1 4-mark question. So total, you will get 9 marks from this chapter. So let's look at what are the types of question they may ask you for 4-mark and 5 marks question. So 4 marks question, usually they will ask you expansion of the numericals using binomial theorem. So let us take few questions. Find the value of 0.99 whole power 5 using binomial theorem up to 4 decimal places. This was asked in March and July 2016. Now we know the binomial expansion, that is a plus b whole to the power n can be written as nc0 a power n plus nc1 a power n minus 1b plus nc2 a power n minus 2b square plus etc. We have at last ncn b to the power n. So using this binomial theorem, we have to explain this 0.99 whole to the power 5. Now 0.99 whole power 5 can be written as 1 minus 0.01 whole to the power 5. So here we can take 1 as a, and for the value of b, we can take it as 0.01. So let us expand using the term we have. N is nothing but 5, a is 1, b is 0.01. So the first one is 5c0, 1 power 5. Next 5c1, 1 power 4 into 0.01. Next 5c2, 1 cube, 0.01 whole square. So here we have b in the form of minus. So we will substitute minus here. Here also we will substitute minus. Next we have 5c3, 1 square minus 0.01 whole cube. Next 5c4, 1 into 0.01 minus 0.01 whole power 4. The last one is 5c5 minus 0.01 whole power 5. Now let us expand this. The first one is 5c0, which is nothing but 1. 1 into 1 power 5, we have 1 plus. Next we have 5c1, which is nothing but 5. 5 into minus 0.01. Next we have 5c2, which is equal to 10. So we have plus 10. We have 0.001. 01. Now for the next term, if the expansion of 0.01 whole cube, it goes more than 4 decimal places. Here we can round off to the places where we have 4 decimal places. So therefore I will stop here because I have 4 decimal places. Now let us expand this. We have 5c0 into 1 power 5, which is nothing but 1. Next we have 5c1 into minus 0.01, which becomes 5 into 0.01, and here we have minus. Next we have 5c2. 5c2 is nothing but 10. 0.01 whole square becomes 0.0001. Next again we have 5c3. 5c3 is also nothing but 10. So we have here 0.01 whole to the power cube. So we have 0.000001. And similarly, we have these two expansion, but it is not necessary because we have more than 4 decimal places in the 4th term itself. So therefore, we can stop here. Now let us multiply 1. Here it becomes minus. So here also minus 0.05. Next this becomes 0.001. Next this becomes minus 0.00001. So on finding the value of this, we will get the value as 1.95099. So this is the value of the given expansion of the term 0.99 whole power 5 up to 5 decimal places. Next question. Find the value of 1.01 whole power 5 using binomial theorem up to 4 decimal places. So here it is July 2017, March 2018 and July 2018. So now let us expand using the binomial theorem. So 1.01 can be written as 1 plus 0.01 whole to the power 5. So 1.01 whole power 5 can be written as 1 plus 0.01 whole to the power 5. So now let us expand this. So this becomes 5C0 1 power 5, 5C1 1 power 4 0.01, 5C2 1 cube 0.01 whole square, 5C3 1 square 0.01 whole cube. Next 5C4 0.01 whole power 4, 5C5 0.01 whole power 5. So let us write this. This is 1 into 1 power 5 1. So 5C1 is 5, 0.01 it becomes 0.01 into 5. Next here it is 10 into 0.0001. Next again it is 10 into 0.000001. So we can stop here because we have to take up to 4 decimal places. So the other two is not required because we will round it off to 4 decimal places. So what does it becomes now? So it is 1 plus 0.05 plus 0.001 plus 0.00001. So adding all these terms, we will get the value as 1.0510. We will get, since we will stop up to 4 decimal places, we can write only this value 1.0510. Next question. Find the value of 1.2 whole power 5 using binomial theorem up to 4 decimal places. Now here 1.2 whole power 5 can be written as 1 plus 0.2 whole to the power 5. Let us expand this, which becomes 5C0 1 power 5, 5C1 1 power 4 0.2. Next we have 5C2 1 cube 0.2 whole square. Next we have 5C3 1 square 0.2 whole cube. 5C4 1 power 1 and here 0.2 whole power 4. Next we have 5C5 0.2 whole power 5. So the value here it is 1 and here it is 5 into 0.2. Next we have 10 into 0.04. Next it becomes 10 into, it becomes 0.008. So next one is 5C4, which is 5 into 0.0004. And the last one we have 1 into 0.00032. So by multiplying and adding the value, we will get the value as 2.4883 etc. But we can round it off to 4th decimal place. Hence the value of 1.2 whole power 5 is 2.4883. So for 4 marks question, they will give you the expansion of the numericals in terms of powers using the binomial expansion. Next we will move on for 5 marks question. So for 5 marks question, since you know the expansion of the binomial theorem, you need to learn the general term. So using the general term of the binomial expansion, they may ask you to find the particular term in the expansion or the middle term in the expansion or the coefficient of particular term or the term independent. Term independent means the constant term which contains in the expansion of a binomial theorem. These are the 4 types they may ask you for 5 marks question. One is the general term, middle term, term independent and coefficient of particular variables. So here let's see the question. Find the coefficient of x to the power 5 in the expansion of x plus 1 by x square whole to the power 17. Now we know the formula for general term, that is TR plus 1 is equal to NCR a to the power n minus r b to the power r. So here we need to find the coefficient of x to the power 5. So we doesn't know what is r. Let us keep it as it is. So n is nothing but 17. So 17 CR. A is nothing but x. 17 minus r. B is nothing but 1 by x square whole to the power r. On solving this, we get TR plus 1 is equal to 17 CR x to the power 17 minus r. Here we have x square into r becomes 2r. When we shift it to the numerator, it becomes minus 2r. So therefore, here we have TR plus 1 is equal to 17 CR x to the power 17 minus 3r. Now, to find coefficient of x power 5, so compare these two. X power 5 is equal to x power 17 minus 3r. So this implies 5 is equal to 17 minus 3r. So here we get 3r is equal to 17 minus 5, which is equal to 12. So r is equal to 4 we get. So therefore, if you substitute r here, then it becomes T4 plus 1 is equal to 17C4 x to the power 17 minus 12. So which becomes T5 is equal to 17C4 x power 5. Now we have the variable x to the power 5. So therefore, the coefficient of x power 5 is 17C4. So this is the coefficient of the given particular variable. So using the general term, we need to get the general term of the given coefficient. Now comparing the variable with the power, we will get the value of r. If you substitute the value of r here, you will get back the same coefficient. So therefore, the coefficient of the variable is 17C4. Next one, find the term independent of x in x cube minus 3 divided by x square. Remember, term independent is nothing but we need to equate the coefficient of x with respect to the power 0. So same procedure as we found the coefficient of x by comparing the powers. Here we are comparing the power with respect to 0. Now let us write the general term. We know it is TR plus 1 is equal to NCR a to the power n minus r b power r. So TR plus 1 is equal to, so we have here 15 CR, value of a is x cube to the power 15 minus r, b is minus 3 divided by x square whole to the power r. So this becomes TR plus 1 is equal to 15 CR. This becomes x to the power 45 minus 3r, and here we have 2r, which becomes minus 2r into minus 3 whole to the power r. So TR plus 1 is equal to 15 CR x to the power 45 minus 5r minus 3 whole to the power I. So to find the term independent, we have to put 45 minus phi r to 0, because term independent means it contains clearly only the constant term, not any variables. So therefore from this we get phi r is equal to 45. So therefore r is equal to 9. So substitute r is equal to 9 there. If you substitute r is equal to 9, then it is t9 plus 1 is equal to 15c9. 45 minus 45 becomes 0. So x power 0 is 1. And here it is minus 3 whole to the power 9. So this is the term independent, or we can say the 10th term is the term independent. 5c9 minus 3 whole power 9. You can clearly see here there is no variables except constant terms. Next question. Evaluate root 3 plus 1 whole power 5 minus root 3 minus 1 whole power 5 using binomial theorem. So, expand root 3 plus 1 minus root 3 minus 1 whole power 5 using binomial expansion. So, let's see what is root 3 plus 1 whole power 5. We get 5c0 root 3 plus 5c1 whole power 5, this is 5c1 root 3 whole power 4. Since we have b value 1, how many times the power of 1? It becomes 1 only. So next we have 5c2 root 3 whole cube. Next we have 5c3 root 3 whole square. 5c4 root 3 plus 5c5. So next we have root 3 minus 1 whole power 5. So with the expansion of minus 1, first one is same 5c0 root 3 whole power 5. Second one becomes 5c1 root 3 whole power 4 minus 1, which becomes minus. Next is 5c2 root 3 whole cube minus 1 whole square becomes plus 1. So here it is plus. Next here it is again minus 5c3 root 3 whole square minus 1 whole cube is minus 1. So we will get minus here. Next the last one is same. Here we get minus 1 whole power 4, which we get back 5c4 root 3. And the last one is minus 5c5. So now let us subtract this. To subtract, change the sign of each term. So if you subtract, then it becomes root 3 plus 1 whole power 5 minus root 3 minus 1 whole power 5 is equal to 5c0 minus 5c0. These two get cancelled. So plus minus of minus becomes 2. So therefore it is 2 5c1 root 3 whole power 4. Next these two get cancelled. Next we have plus 2 5c3 root 3 whole square. Next we can cancel these two. Next we have 2 times 5c5. So here we have root 3 whole power 4, which is 3 square 9, 9 2s are 18, 5c1 is 5, 18 5s are 90. Similarly root 3 whole square is 3, 5c3 is 10, 3 into 10 into 2, which becomes 60. And the last one is 2, 5c5 is 1, so it is 2. So when you add this, the value you will get it as 152. So this is one type of question they may ask you, that is using binomial expansion, find the value of the given particular binomials. Next question, find the middle term in the expansion 2x square by 3 minus 3 divided by 2x whole to the power 10, which was asked in March 2019. So since here n is equal to E1, middle term is n by 2 plus 1th term. So n is nothing but 10, 10 by 2 is 5, plus 1 is 6. So therefore T6 is the middle term. So now let's find out T6. So T6 can be written as T5 plus 1, because we need to write this in the form of TR plus 1. Now we have NCR, which is nothing but 10, C, R is 5. A to the power n minus R, that is 2x square divided by 3 whole to the power 10 minus 5, and b is minus 3 by 2x whole to the power 5. So here it becomes 10c5. So this is 2 to the power 5, x to the power 10, 3 to the power 5 into, here it becomes minus 3 to the power 5, 2 to the power 5, x to the power 5. I'll write minus 1 whole to the power 5. So we can cancel 3 power 5, 3 power 5, 2 power 5, 2 power 5. So therefore T6 is equal to, outside we have minus 10c5, x to the power 5 to the power 10 get cancels, x power 5. So this is the middle term of the binomial expansion given. So these type of questions you may find from the chapter Binomial Theorem. We'll meet you in the next session with the new chapter. Until then, keep watching, keep learning, keep exploring. Thank you.